Assalamualaikum everyone, my name is Arsalan Farrukh and I teach math and physics. In this video, I will discuss some concepts related to complex number. So first of all, we need to identify or recall a fact that sometimes when we are solving a polynomial and we get our answers, we may get into a situation where we have a negative sign inside the root. So such situations, we have complex roots or unreal roots, and these roots can be represented in terms of iota, where iota is under root of -1. So once we get these numbers, we can represent these numbers on an Argand diagram. Argand diagram is just simply a vector diagram representing all the complex numbers where you put the real part of the complex numbers on the x-axis and the imaginary part of the complex number on the y-axis. Like if you have a number which is 1 plus 3 iota, so that means you put 1 on the real axis, that is the horizontal axis here, and 3 on the imaginary axis, and hence your number is going to be represented as a vector on an Argand diagram. So 1 minus 3 iota would be exactly a similar vector in the opposite direction below the horizontal axis. So likewise, you can represent all the numbers, even you can represent real numbers. Like for example, if you have to represent a 2, that would be just 2 units on the real axis. Or if you have to represent a number which is just having an imaginary part, let's say 3 iota, so you can represent that 3 iota on the Argand diagram like this. So all the numbers can be represented on the Argand diagram in the form of a vector. The other thing that you must understand is that once you have represented a complex number on the Argand diagram, you can also represent that complex number in the moduli argument form. Now, modulus of that particular complex number is basically the length of this vector. An argument of that complex number is the angle that it makes with the positive real axis. And you should keep in mind that the range of argument is taken from negative pi to positive pi. That is like your complete possible range in which you can represent the complex numbers. So if you have drawn a complex number on an Argand diagram, the modulus of that complex number would be the length of the vector, and the argument of that complex number would be the angle that this particular vector makes with the real axis. So like for example, if you have a vector which is represented on the second quadrant like this, so the length is going to be the modulus, and the entire angle from here to here, that is going to be an argument. So the length of the vector can be found out by just simply using a Pythagoras theorem, which is called the modulus of z, and modulus of z or is basically under root a square plus b square. So that gives you the length of the complex number, and then you would also want the argument of the complex number, and the argument of the complex number can be found by using the tan ratio. But remember that when you find the tan ratio, you should take the modulus of b and a so that you get a positive value and you just get the basic angle of that. And you can use these formulas to turn those basic angles into argument. In the first quadrant, the argument would be the basic angle itself. In second quadrant, the basic angle that you will get, you need to subtract that from pi to get yourself the argument. Similarly, in the fourth quadrant, it will be just minus of that basic angle. And if you want it in the third quadrant, you will get the basic angle, and then the argument is going to be basic angle minus pi to get yourself the overall argument from the positive real axis. So this is how you can represent all the complex numbers into their moduli argument form. So like if I would take an example of 1 plus 3 iota, its modulus is going to be modulus of this complex number x is going to be under root 1 square plus 3 square, and if I take 1 plus 3 iota only, so its argument is going to be tan inverse 3 upon 1. And in case if I take 1 minus 3 iota, then the argument is going to be minus, applying this particular formula for the fourth quadrant, it will be minus tan inverse 3 upon 1. So that's how I can find myself the modulus and the argument of any complex number. Now, the other thing is that these same complex numbers can also be represented in the exponential form or using the Euler's formula. So this a plus b iota, this is the rectangular form of the complex number. Once you have found the modulus and argument, then the moduli argument form of the complex number becomes z equals r cos theta plus iota sine theta. Now, this is very similar to this because if you would look at this expression closely, r cos theta would just be the x and r sine theta would just be phi. So r cos theta turns back into a and r sine theta turns back into b, and we'll come back to that particular form. So this form here, z equals r cos theta plus iota sine theta, is called the moduli argument form of this particular complex number. And you have to make sure that whenever you find the argument, you have to make sure that the argument lies between an interval of minus pi to pi. Now, you have modulus and you have an argument. You can, after expressing any complex number, you can use an Euler's formula to write it down in the exponential form as well. That is something you can directly state. So if you have z equals r cos theta plus iota sine theta, you can directly write it down in the exponential form using the Euler's formula, which is going to be r e power iota theta. So if you're finding out the complex conjugate, we already know that you just have to change the sign of the imaginary part. So if I have it in the moduli argument form, its complex conjugate would be the one which has a minus theta in it. Cos of minus theta becomes cos theta and sine of minus theta becomes minus sine theta. So you can also write it down as cos theta minus iota sine theta. So you can also write it down as cos theta minus iota sine theta. And if you have Euler's form or exponential form of a complex number, then its conjugate is going to have its angle being reversed. So a plus theta is going to become minus theta. So if z is e power iota theta, z conjugate would be e power minus iota theta. Or if z is k plus e power iota theta, then its conjugate is going to be k plus still, only the angle will have its sign changed. So I hope, guys, this was useful in terms of identifying what is the moduli argument form, how you can find the moduli argument form of a complex number, and how you can write it down in the Euler's notation. If it was helpful, I would really appreciate if you'd like the video, subscribe to my channel, and also share it with your friends. Thank you.